David Franks has an interesting career over 10 years in many parts of the aviation world. At US Airways and American Airlines, he performed runway, takeoff, obstacle, and various other, sorry, not runway, takeoff, obstacle, and various other performance analysis for the airlines. While working for an aircraft simulator company, he created aerodynamic flight models for multiple aircraft and helicopters. Currently, David works in the aerospace standards team at SAE International, focused on advanced air mobility to help build consensus solutions that move the mobility industry forward. So welcome, David, and over to you. Thanks.
Okay, fantastic. So here we are, standards to enable UAM and AAM. Now, of course, there's a lot of terminology out in the world, and that's a lot of the work kind of we're doing is we want to rein in this term so that there's a concrete and uniform example of what we're working on. AAM, I think, is the global term, of course, advanced air mobility. We have UAM, urban air mobility, which really dictates that intra-city Uber-like experience with the air taxis, typically eVTOLs at this time. Of course, I think as the industry progresses and moves on, and as we've seen more recently too, at least in the United States, with the investments from the major airlines into the AAM world as well, it's going to move into more of what they deem RAM, which is going to be the regional air mobility, more of that city-to-city connection, you know, as well as progressing into larger and larger distances. So it's an exciting field. As you can see here, and I know David Alexander spoke on a lot of these key technologies that SAE strives to do, but a lot of these, of course, are interwoven into the AAM world, and a lot of these technologies being driven by the AAM world in the industry as well. So it's exciting to be a part of these great technologies. And I'm going to walk through a quick baseline on SAE and our focuses, and then I'm going to walk through the airspace standards, the specific committees that are working on AAM, the work in progress, which is the latest activities that were going on, as well as some of the more exciting newly published documents as well. So I know David gave us a nice brief overview of SAE. You know, our mission, of course, is to strive to be a leader in connecting professionals around the world to come together and improve mobility solutions. And those keys are really to give those industries and those people a neutral forum where professionals can come together to work together and address the collective problems they face. As David Alexander spoke about, India has great participation. The region is fantastic. And of course, a lot of the people here today already understand that and see the value in the forum that we provide to progress the industry forward. So a particular focus that we've been working towards is to create the stronger links between our standards and certification. Of course, I think that the number one step for a lot of the AAM OEMs, of course, is to get that certification route. So what they need, especially with more and more performance-based requirements with this new technology, some of the regulators are moving towards these requirements that are based on performance, that they need to utilize these consensus-based standards that we are capable of helping produce, the industry produce, that they detail these high-level means of compliance, or, you know, termed MOCs. So we really look to our steering groups and our system-level groups, which sit atop our committees. And we look to them to create these roadmaps and guidance that come down and make sure that we're on track to produce exactly what the industry is needed. Of course, we're in constant cooperation with STOs and regulators around the world. Working with other STOs not only prevents duplicate work, which of course with everybody here in the forum that participates with SAE knows it's no joy to see, you know, to be involved in other STOs as well and see similar work going on at the same time. It doesn't help us, and it certainly doesn't help the industry move forward. So what we do is we have active collaboration and cooperation with multiple committees around the world. That includes EuroK, IEEE, all the regulators, FAA, EASA, other STOs like ASTM, RTCA, and higher level international organizations, including ICAO. And others. So what the scope of communication and involvement with the regulators is, it's a great two-way exchange. So they get industry perspectives and needs, they can reach the regulators, and the regulators' goals and developing requirements can help inform both industry and standards. And a lot of the success we've seen, especially when forming new committees or new efforts, even new documentation, is that we can get the regulators on board, industry tends to follow. So again, it's a great tool that SAE provides to both industry and regulators for that forum where they can both come and speak a little more openly and make sure that they understand each other. So everyone involved in AAM understands the challenge in certifying these vehicles, involving the FAA and EASA and other regulators around the world. And this helps bring that cohesive roadmaps and solutions to bear. We hear it over and over again out in the conferences and speaking with the regulators and especially with the OEMs in the AAM. And they use the term, they want consensus standards and they want them more clearly wrought out across the industry, right? They don't want ASTM and SAE to develop different standards, especially for different regions as well. So both globally and across STOs, those OEMs are looking for these unified standards that present one clear path to certification first, and then onwards towards producing the additional technology and supporting their operations as they're out there in the world. So a lot of technology being used and developed for AAM is also present in the advancing ground vehicle and automotive world. Self-driving cars, hydrogen-powered buses, electrification, AI, public acceptance, just a few examples of this crossover in the tech. And that's really a strength of SAE as we have these two standards programs, right? We have aerospace and we have the automotive and the ground vehicle sectors. And they could both benefit from each other's successes. A lot of, especially hydrogen is a great example. Hydrogen buses have been driving around for years now, as well as electrification with charging ports, as well as that industry being advanced on the ground for years. There's a lot that the aerospace and the AAM world can learn. And that's a strength for SAE, and what we're striving to do is to connect those two industry groups together so that existing tech and standards can be pushed over to the aerospace side for either quick adoption or maybe slight modification to make it work exactly with AAM and to prevent, again, duplicate work and speed it up to an eventual standards publication so that, again, we produce those standards more quickly to help advance those industries move forward. So the driving factor for AAM is to improve aviation's impact on the environment, of course. And we hear that again over and over out in industry, talking to the OEMs and as well as the supply chain makers, as well as the regulators and the city environments and the politicians and the people that are providing some of the funding and things as well. If it's not sustainable, then they don't want it. The investment isn't there. The industry is, of course, driven extremely by the environmental concerns. So aviation alone accounts for around 2% or more of global emissions. And although we're not a major contributor there at 2%, the industry at large is working to reduce those emissions down to as low as possible. So for example, we support multiple efforts in that realm, not alone with just base standards activities in our committees, but also supporting ACAR, REACH in Europe, ICAO's targets, and other key initiatives around the world. I know David Alexander already went over this chart, so I'll just briefly, say we have over 180 plus committees, thousands and thousands of individuals, including, you all here today around the world. And we had nearly 700 standards published in 2021. And I believe we're on pace to achieve that and more this year as well. SAE priority topics for the year. We set out many priorities, which of course involve AAM. They include advanced materials and manufacturing for VTOL, digital and data steering group, a joint effort with EuroK on artificial intelligence, our modeling and simulation and training group, that's G35, as well as, which is very exciting, a new supersonic steering group. So even though I don't think a lot of VTOLs are planning to go supersonic, it's another part of this new wave of aviation that's exciting to be a part of. So again, here's a brief summary, a very nice pictorial on the different groups. And I'm going to go into some further detail here on exactly what some of the groups are that are affecting AAM, so specifically their works in progress and the newly published works. So we'll start with our E40 committee, that's electrified propulsion. And they've worked here, and what I'm showing here is a bit of a roadmap, which is a key tool that we guide some of our committees to in their initial setting, as well as what we look to from our systems group, our steering group, is to produce these roadmaps. So here they've worked to review their collective needs and they judge them events against their importance and requests from the industry versus the time that we needed in the industry. So up in the far right, you'll see the most important and most needed topics involve certification and compliance, of course, right? Before anything, these things need to be certified and compliant with local regulations as well. And these are ever-evolving topics, but these roadmaps are the key to make sure that we weigh the relevance of what they're after and make sure that we utilize the best resources at hand. So E40, again, it has two newly published documents that have come out this summer. We have an ARP and an AIR 8676, which is a nice foundational nomenclature and definitions, as well as AIR 8678, which is an architecture examples for electrified propulsion aircraft. So these are both foundational documents, and it's a great starting point. A lot of times with new committees and new technological topics, it's important that these taxonomy, verbiage, and wording are all worked out and defined clearly, so that the committee itself, as well as industry, all move forward speaking clearly and using the same terminology, which is important that they all understand each other moving forward. They align the terminology, and it's of course a baseline foundation for consistent communication and these future developments. It's a very active committee. We see a lot of participation from a lot of the OEMs across the AAM world. I believe it's currently chaired by a gentleman from Lilium, the German OEM. They're now focusing on safety, endurance testing, and considerations for ground support operations. So with the electrification of these aircraft, especially moving to high voltage, maintaining these aircraft, and even refueling in whatever sense that may take with the different versions of the electric aircraft, ground handling of these high voltage battery systems and engines becomes a training issue and a knowledge issue. So they've moved on to work with that. And we also coordinate this group with EuroK and ASTM. So again, speaking of high voltage, we have our AE10 high voltage committee, which is of course focused on the more intricate versions and details of that AE10. So with the use of the new and more powerful forms of electric propulsion in the aviation comes the needs for these higher power voltage. So these new challenges include propulsion systems, wiring, installation, safety, and charging. And that is our AE10 high voltage committee. So they've formed 6 subcommittees over what they've deemed the most important kind of subtopics: systems, energy storage, EWIS, equipment and the device itself, user safety, as well as infrastructure. So a lot of their key documents I have listed here. We of course started with definitions, and that's our aircraft electrical voltage level definitions. We have impact on high voltage on wiring. Both of those have been published, and we have a third document here which is close to finalization, and that's aircraft high voltage DC power quality standard. So along with electrification, hydrogen and fuel cell technology is also developing closely with AAM as another alternative to traditional fuels. With battery technology's current weight to energy ratios, hydrogen is poised to have a great impact at longer distances. I think as the industry matures and the technology is accepted and the public and operations begin, the electrification, I think, will run out of range a little bit, and the industry is looking, especially with the larger aircraft types, towards hydrogen. So hydrogen presents several challenges, both on the aircraft as well as the infrastructure to support it. So our AE7F committee is working with EuroK, Working Group 80, to help advance these technologies and help solve these problems. They have 3 published standards, I think, that are key documents that they've used as a foundation. And they also have some newer work that's in progress, which is liquid hydrogen storage for aviation and gaseous hydrogen storage for aviation. So again, when using hydrogen, that's the 2 main choices so far. Both prevent different challenges, including temperature regulation and storage and different pressure ranges. It's exciting to see all the different new designs from the UAM and AAM realm. Some of these designs are pushing the bounds on structures and materials to save weight and increase performance. To accomplish this, new manufacturing techniques, new materials, and new uses for existing products abound. SAE has multiple committees and subcommittees established that are working on some of the key aspects such as additive manufacturing, composite repair, polymer matrix composites, really trying to serve the number of needs that these, again, especially with the smaller eVTOLs and these initial rounds of OEMs are really creating these unique vehicles with unique design challenges. And of course, consistent everywhere with aviation is the drive to get that weight down as much as possible to optimize performance. A great example here is the VTOL seats committee that we already have. And this is a great example of where we took existing publication in a standard that was written, of course, well before AAM realm, but was quickly adapted to help and serve the need of the AAM realm. So they had a kickoff meeting held in just July of 2021 with great representation from regulators, EASA, FAA, the UK CAA, as well as AAM industry members, Wisk, Lilium, Safran, Honda, Bell, Collins, and then they did produce that. And it says they're balloted to council, but it has been published, AS 6849, which is performance standards for passenger and crew seats, specifically for advanced air mobility aircraft. So again, I'd like to bring this up as a great example of where we took existing standards. We took it to the regulators and we involved the regulators and the OEMs and the industry itself. And we said, we have an existing standard. Can we quickly adapt that to what you need and really cut the time down from, of course, starting a document from scratch? A paramount concern for everyone involved in AM is, of course, safety. New designs, new technology, flying new mission protocols requires that care is taken to safely design, test, and operate these aircraft. So the SAE S-18 Aircraft and Systems Development and Safety Assessment Committee develops and maintains guidelines for processes, methods, and tools to accomplish the development and safety assessments of aircraft, systems, and related equipment. The group is dedicated to creating, preparing, and maintaining all the relevant specifications, standards, and information material for effective commercial aircraft development and safety activity management. Another exciting aspect to the future of AAM is the use of artificial intelligence and machine learning in these aircraft. The promise of UAM and AAM to deliver a safe, equitable, and publicly accepted new era of aviation will require a fully integrated airspace with thousands of these new aircraft operating in various mission profiles without a traditional pilot on board. Artificial intelligence, of course, will be a pivotal in making this happen. And that is exactly what SAE's G34 committee focuses on. It was formed jointly with EuroK. Their first standard was published in 2021. And with a wide range of global participation throughout the world's aerospace industry, this group is positioned to help UAM and AAM develop and deploy AI safely and successfully. And it's a key topic you see from the AAM world and the OEMs. Of course, realistically, these operations will start as 1 or 2 flights with limited operations and ranges. But as their business models dictate in the longer term, they're all driving towards fully autonomous, fully integrated into the airspace, operating without pilots, or perhaps a new terminology, person in control from a remote ground station or dispatch. Another key group that we have here is SAE's G35, which is modeling, simulation, and training. A key to the AAM success will be the use of new, efficient, and safe methods for training, pilot crew certification, and the use of simulation. Simulation in particular is used in model development, flight testing, and training, with new technologies emerging and the role of the pilot and crew changing with some of these new aircraft designs, if not all of them. There's a need to develop guidance on best practices for modeling, simulation, and training. So our G35 committee was established to bring industry together and solve these problems and provide that guidance to the AAM ecosystem, passenger cargo aircraft OEMs, flight simulation training device manufacturers, as well as everyone involved with crew certification. So they've broken off into 3 subcommittees. We have G35A, B, and C, both focused on key topic areas: aircraft system development, simulation, and human trainings. It's in multiple standards in progress right now. They have listed here taxonomy, again, another foundational document clearly defining the technologies at hand, pilot training and qualifications specific, again, to VTOL capable aircraft, technology standards for VTOL capable aircraft training devices to support evaluation, as well as modeling and simulation to support certification of aircraft and avionics. Again, that first step to a lot of these key technologies, especially new to the regulators, is getting them certified, involving them into these committees and these processes early is key to keeping that industry aligned and moving forward so that they don't get too far ahead without complying with the regulators. So along with safety, noise is a primary factor in public acceptance with these new aircraft. The promise of thousands of new aircraft flying in urban, suburban areas brings the concern of how new noise profiles will affect the population around where UAM, AAM will operate. Almost everyone knows the sound of a loud helicopter beating its way through the air, or even of a small quadcopter buzzing and whirring over our heads. The different configurations of rotors, of loading on the different propeller sizes and motors of these new aircraft will have to fall into an acceptable level of noise, depending on how and where they operate. Again, speaking to a lot of the regulators, and really at our level, at least in the United States, we have the city authorities where these will operate, and as almost their primary concern, of course, besides safety, is where will these operate, how loud will they be, and will they be able to operate below, of course, current noise thresholds, be able to operate without the public kind of rejecting the level of noise that they bring as a nuisance to the areas of where the vertiport may be, or additionally to added noise to existing airport infrastructures. So what we have is SAE's A21, and it's an established committee already, and that focuses on aircraft noise measurements and aviation emissions. And of course, noise can be viewed as an emission. And some revisions to existing documents have already been made to prepare for AAM, and there are other relevant works in progress as well. That work in progress example is monitoring aircraft noise and operations in the vicinity of airports. That describes system description, acquisition, as well as operations. So again, I view this as a key committee. The industry itself, of course, has identified noise as really a key requirement to allow them to operate. So I know work is going to continue here in our A21 committee on noise for the eVTOLs and the AAM world into 2023 as well. So real quick here, we have in the new year, of course, Aerotech in Texas, which is our seminal aerospace conference for SAE. AAM will feature prevalently, of course. That is one of our key focus topics and includes so many great technologies coming into the world and being pushed through all around the world. So again, I want to say thank you for the opportunity to speak, and back to you.
Thank you, David. Thank you for the interesting presentation and sharing details of various standards that SAE is working on with the community. So we are doing good in terms of time. Probably we can take few questions. David, is that okay?
Yeah, sure.
Okay. Yeah, let me see in Q&A window. I don't see any questions. I see a few questions in the chat window. Yeah, so there are a couple of questions. Let's see how many we can address. Do you look at ISO standards which are being developed? If yes, do similarities, with other standards?
Sure. The ISO standards?
ISO standards, yep.
Yeah, we recently participated at the international level. The ICAO organization, headquartered up in Montreal in Canada, held the term was RPAS, which is remotely piloted aircraft systems. So they had a forum here about a month ago that we participated in. And it was a good example after we had a specific roundtable with just the SDOs with their RPAS panel. So it's really key and relevant to all the SDOs, especially, of course, us as SAE, with the regulators. But to help serve industry best, we need to present a unified front, and we do actively communicate with all the major SDOs to speak about what are we working on, what are our key focus areas, and to make sure that we don't cross communicate, that we don't duplicate our efforts. We don't want to be moving ahead and wasting industry's time by developing two standards. And again, as probably a lot of people on the call may be involved with multiple SDOs can tell you, and a lot of times we hear from members themselves is, hey, we're already working on this with ISO. We're already working on this with ASTM or RTCA, which is fine. There's plenty of work to go around, but we work hard to communicate with all of the SDOs to make sure that we don't duplicate those efforts and are aware, try to be as aware as possible of the other work that's going on.
Sure, that's great. Thank you. Maybe let's take one more question. So do we have any standards coming up when it comes to hydrogen production and transportation, as that's one of the main issues?
Yeah, I believe that our hydrogen committees, and I know they're in different stages of the technologies and what they're looking after. I'd say to go and reference my slides, I'm sorry, but yeah, our hydrogen committees, I'll have to check what are exactly their works in progress are, but I know they're actively looking for everything, and infrastructure, becomes probably the key limiting factor for initial operations. It's spoken about a lot. I know when we speak to the people that are most interested in hydrogen is how do we transport it, how do we fuel, what are the limiting factors on getting it on and off the aircraft. A lot of the interesting ideas that I think we're looking to pursue more in 2023 and beyond with hydrogen is a grander topic, which is the airport as an energy hub. So with hydrogen, with electrification, is there opportunities there for operators, for airport infrastructures to create this new hub of energy where there's hydrogen resources, electricity resources, as well as traditional fueling resources. So yeah, I think for sure that's a key concern for a lot of people, and it's definitely in the works throughout our hydrogen committees.
Excellent, excellent, David.